Okay. All right, great. So welcome team for the recording. Today we are getting into session 12 of the training. So we'll discuss evaluations. Last week, in the last session, we had talked about monitoring and tracing. And then we said we'll explore a little bit about evaluations. What is evaluation, and then how do we do it with the LangWatch, where there are off-the-shelf evaluators that are built in. Some of it is also works as guardrail. Some of it is just evaluation, of the model, how it is uh, by default doing the evaluations of detecting the PI. Sorry, somebody has a question. Morning. All right. So we go to evaluations, right, in the LangWatch. So that's what we will do. And then today we will get started about building, starting projects, building projects like we were doing Python scripts on Collab. So we will get how to start build a project with the VS Code. And next, tomorrow we will also get into full-fledged code with deployment. We'll explore the deployment as well tomorrow. And also today we'll talk about, we have been talking to the models through the API, OpenAI API with the key, right, on the cloud. So how do we deploy locally any open source models and then use it locally? Okay. So that also we will talk about today. And then there's a bit of guardrails towards the end. We can talk, we'll take up in the future sessions. So in the work, so we have in the LangWatch, we talked about the last week traces and monitoring, right? How your LLM calls are traced and how you can look at various metrics and visualizations. And then how do you evaluate a model? Okay, so if you go here, if you create a workflow, it'll give you a lot of evaluators here. So basically, an LLM model, whatever you're giving a question, gives a response, right? So how do you test an application or any workflow where a model is involved? In the traditional applications, right? What do we do? In the traditional applications, we write test cases, correct? So what test cases we write? We have a scenario where we give some input to the application and we have some expected output from the application based on the requirements. So what does the testing do? Testing does, if we give a given input, does the output from the application match what we are expecting it from the application? So it's basically matching the expected output to the actual output for a given input. That's what we do in the testing. That's at the basic level, right? Now, what happens if a model is thrown into the mix, LLM model? So we all know LLMs are non-deterministic in nature, right? So there is no fixed answer or output that comes out of a model every time for the same input. We already have been talking about it, that for a fixed input, same input multiple times, you cannot expect the same answer. You can expect a similar answer, but not the same answer. Now, when you say similar, not same, how do you evaluate? And then what parameters do you evaluate on a model particularly? What parameters do you evaluate is your hallucination, right? Or completeness of an answer. Is it complete? Factual. Is it factual? Is it correct? So it's the correctness. It's the the factual, where is it true, is it complete. So these kind of evaluations you can do on the model, basically how closely related to the expected output semantically. So for that, there are several parameters and then several evaluators that are off the shelf here. But then again, you can also build your own evaluators. Like- so there's some frameworks also. So what does it do is the exact match. If you see here, so these are all evaluators available. Okay. So if you see exact match, this is our standard uh, truth, ground truth that we say. If we give an expected output, does it exactly match the actual output from the model? This is our traditional testing that we can do. So how do we test here? We give a set of a data set for testing, test data set. We have an actual, we have expected output. So the question and the expected output as a test data set. So we pass the question to the model, and then you get a response. And then you also pass the expected output to the model, to another model. So the new model or the evaluator will take both the actual output from the model and the expected output you are sent and compare it to see and give out a answer, whether it can be a percentage, it can be a Boolean, yes, no, pass, fail kind of a thing, based on what you want to check. So you see here data set, right? So if you go here and say, look at data sets, have data sets here. You can go here and say data sets. So you can create your own data set, use AI here to create data set. Okay. Now I have created a few data sets here. Okay. If you go to this, what does it do? So input and output. How can I reset my password? I received a damaged product. How can I track my order? So these are all very specific to my company. Probably I'm using RAG to answer these questions. But when the retriever gets it and the model answers the question, how close is it, or how exactly match to my answer what I'm expecting here? Is it giving the exact answer what I'm expecting, or is it giving something else? That's what we evaluate. Okay. Now, there are different data sets. I have input and output for question and answers, where we can use for different test cases. Where's this data set? Test data set. Okay. So here I have only the input. There's no expected output here in this. So if we go back to workflows, if we go here, so what are the different evaluators we have? Exact match we talked about, and we have a LLM answer match. What does it do? It uses an LLM to check if the generated output answers a question correctly, the same way as the expected output, even if the style is different. So we are using another model, right, to verify if it is giving the correct answer as expected. The same thing here, LLM as judge. It uses an LLM as a judge with a custom prompt to do true or false evaluation of the message. You give some message and then it will evaluate it as a true or false based on the your prompt. This can also be a score. It's like 50%, 70% correct, or 80% complete, factual, or it can categorize with the prompt, whatever you give. So you're basically using another model to evaluate the input and output, sorry, not the input, the answers of a model. So let's take this. If you see here, LLM answer match, it has input output and expected output. You just drag and drop these components into the workflow. So the input is basically your actual question. Let me. Input is your question that you are asking the model or asking the application. Output is the actual output from the model. For what is the answer for your question the model is giving out. Expected output is what you are expecting from the model as an answer. So you have these three parameters. Based on this, it will put out a message whether it is passed or failed. Booleans, true, false, kind of. Okay. So these are the. So same thing, you can drag and drop all of this. So again, there is another framework called Ragas. We'll talk about Ragas and the another one called guardrails when time permits towards the end. Small topics we'll touch upon. It provided it assesses the extent. These are all like same thing but different ways of evaluating it. Okay. Better faithfulness to the context, useful for detecting hallucination. These are like Python-based dictionary, Python-based libraries that you can use to assess the model's evaluation. Okay. These for Ragas there are something, and then there is Blue and Rogue score. These are the NLP metrics. Again, this is another way, natural language processing. What it's just blue is the score for evaluating the similarity between two metrics, how similar they are. This is also another score, similarity between two strings. Both of them give similarity, but they are a little bit different how they are evaluated from the NLP perspective. Okay, so if I go back here and just look at this simple workflow, you have a data set, the same data set I was talking about, the input and the output. So this is actually, this output is what we are expecting it, right? This is the test case we have written. This is the input, and then this is what we are expecting from the model to get the response. So the input, the question I have connected to LLM node. So this goes, the question, this input here, the question goes as an input to this, and the output from the model, we are sending it here. So output from the model goes to the output here as the LLM answer match that we are doing. And the expected output is coming from our data set. So the output, what we are expecting here, becomes the expected output. Now the answer match has the question, the input that we are sending from here, the expected output we are sending from here, and what is the actual output that is coming from the model for that input question. So we are using GPT-4o mini. That's what we are evaluating. Okay. So if you go here and do evaluate workflow, we are running on full data set, 7 entries, batch mode. So it runs each of the test case and then gives out the output score, 67%, 83%, 86%. Okay, totally it gives out 86% that this model matches the answers to the expected output. See, here question is how can I reset my password? The expected output I'm thinking of is that the model should give is to reset your password, go to the login page and click on forget password, whatever is, steps. What is the model giving me? The model is giving me to reset your password. you typically need to follow this general step through the extract process and then go to login page, find the paragraph password. And so it's giving detailed step-by-step instructions. Now, these two are not same. We know that. Even if we look at it, we'll know, hey, these are different. But how close they are, right? Matching, right? It says 1. The predicted answer provides a detailed step-by-step guide on how to read the product, which includes going to login page or blah, blah, blah of this. This matches the essential steps outlined in the gold answer. Gold answer is your output, what you are giving, which are to go to login page, forget password, follow instructions. The predicted answer is more detailed, but does not contradict the gold answer. So the actual answer coming from the model is more detailed, but it is aligned with what you are expecting. It's not contradicting or it's not going against or giving wrong information kind of a thing. So it found the match. Answer matches 1. So it passed. So same thing here. Please contact our support team with your, I received a damaged product. What should I do? Same thing. It covers the action. Although predicted answer is more detailed. It covers the essential action of reaching out to customer service for assistance, which is the core of the gold answer. Right? Now, so these are all okay, matching. Now let's look at something that does not match. What payment methods do you accept? We accept credit cards, PayPal, and bank transfers. Right? So this is what I have put as a company. I am accepting these payment methods. But since I have not given any RAG or whatever to answer, the model has to answer from its own knowledge. Now, what is the model saying here is I don't process payments, but I can process information about, I can provide information about common payment methods in general, if you have specific business platform or mine. So this is what I'm expecting, but this is what the model is giving. So which does not match actually, right? The gold answer specifies the payment methods accepted as all of this. The predicted answer provides a general list of common payment methods. Okay, this is a general list, including credit card, PayPal, but it does not specifically confirm the exact payment methods accepted by the entity in question. Therefore, the predicted answer does not directly match the gold answer. So this is fake. So this is how to, when you are doing any application or any model, any RAG, right? So whatever it is, you build the final output that you are about to send to the customer, that you can feed it here with expected output to make sure that it is passing. So you write your test cases and see if it is low, then you have to tweak your RAG retriever that you maybe are not getting proper results. You have to tweak your prompt, how to provide the answer. So all of that you can do to improve the score. The answer match by the model. So this is like your testing QA for the model or for application you are doing in general. Right? Any questions? So the evaluator is again a model that is checking. So who's checking this actual answer and the expected answer? So that is another model that it is doing, because we cannot write a expected actual output rule-based logic to match, because that does not, right? Only exact match you can write rules if A equal to B. Here it's not like A equal to B. It's if A, the answer, as I said, confirms and provides all the details as per the expected answer. So this is another model. So you can change which model you want to use for your judge, and you can change to benchmark and use. So which model is doing better for me? So you can do both, and then put out your results that, hey, with this model and this model as a judge, with 4.0 mini as my model and the 4.0 as the judge, I'm getting 86%. Now, if I change this model to new model, I'm getting 95%. So some things like that, you can benchmark and choose how you want to evaluate it. Right? Questions?
Yeah, I have two questions basically. So one is like, if you are doing like multiple evaluation, like multiple testing, the output can change, right? And the score might be reduced or maybe increase as well, because LLM is not going to answer, I mean, the same all the time, right?
Yes, absolutely.
It may change. So how will like reach to a point like our testing is okay to proceed for production?
It should not. See, that's the whole point, right? It should not change.
Hmm.
So we got 86%, right? So if we go and do another evaluation, run another time, we know that the answer will change. But again, that's what we are doing the test for, right? It's not exactly matching. It doesn't matter. Say, I will say, what is the capital of India? Expected answer, I will put New Delhi. And when I run it, let's say first time it says the capital of India is New Delhi. Now we say pass. Next time I run, second time it says New Delhi is the capital of India. It changed the order of the words in the sentence, but still it's correct answer, right? So again, it passes. So no matter how many times you run, you should get the same answer. It's okay that the model will give indeterministic, a slightly different sequence of words or sequence of sentences, more or less, but the fact should remain same.
But
Okay.
now see, it's 71%, right? Earlier it was 86 something.
Yeah, shipping address. Yeah, payment method, see, again, it failed. So you can run multiple times and then take an average out. It should not, basically. Last time one failed, this time I think two failed. So um, you have to see why it has failed this time. Last time, did it run it or not run? Direct and specific instructions. So one plus or minus 110% will be there every time you run the evaluations. But it's not like everything fails here. So most of it is consistent. See, if you see the reset your password, this time also you get the same similar answer from the model.
So to fix it, like to be more accurate, we need to implement RAG for this one.
Yes, you need to implement RAG and say uh, in the output, right? So retrieved results in the context, say for example, for this LLM answer match, uh, not shipping address. So let's take this payment methods. So the retriever will get what are the payment methods we accept. So only that it will be sent to the model in the RAG. So the model will obviously output from these only credit cards, PayPal, and bank transfer. So this will match. So that's how, if it's in the rack, this might match. But in general, you have to check. It's not just same or similar kind of evaluation that we do. That is always there. That's why we are using a model to evaluate. But overall, we have to see why it is failing over multiple iterations, how we can improve that, and what is the gating criteria. So let's say if it is 90% can we use, if it is 95% can we use, benchmarking that we can do.
Okay.
Say now this time again it went up to 83%. So this time this passed.
Mhm.
Okay, it's subjective how it finds whether these two are matching, or this all of the information that we are putting in the gold answer is already included in the answer provided by the model, right? So That's how it is. So you do multiple runs and then make sure that it is averaged out or consistently performing better. So you don't run the same thing. You make changes either to the gold answer or you verify if it is correctly the output provided by it is okay for you. So you can change the gold answer and to more closely match or change your RAG to give you better results. So all of that you can do.
So, question. So the score is nothing but a percentage of success over the failure? I mean, the
Yes.
total run? Okay.
Yes. So how many we have, right? Out of 7, if all 7 pass, it will be 100% because here 6 passed, so it's 83%. So here see rows 6 of 7 have passed. Pass rate is 83%. And then for each run, how much it is costing, total cost, execution time, and all of that thing. Okay. Now, so this is one of the evaluation. This is the very basic that you set up and you can do. So there is you feel like almost they are all very similar. Answer match and factual match. So these how closely that your answer is matching with the uh, golden. Factual is how factually similar. I don't know, it looks very similar. What do you mean by factually similar and actual similar, right? So it kind of makes you that whatever it's given is true. Um, it's not hallucinating kind of a thing. Okay, and then you can use language detection. If you give an input in certain language and you are expecting the same, it will verify whether the output language and the expected output language are same, or it's coming it is specific language, or if the language is not there. So those kind of things. So let's see if we go to factual match evaluator. Okay. Now, what is the data set? I have provided this data set. See, where is the Eiffel Tower located? It is located in Paris. Water boils at 90 degrees centigrade. Amazon rainforest is only in Brazil. Mars is known as red planet and all of this. Outputs. And I have a LLM GPT 5.2 here that I'm using. And for the factual match, 4.1 I'm using to match. Same thing again here. I'm not giving the question to the factual match. It doesn't matter what question you are asking. It's only that taking 2 different answers, strings, and then say how they are factually correct. Are they giving out factually correct answers, right? So here the input goes into this model and the output from here and the expected output is sent here. We will run this evaluation. Okay. Why is it giving 0.8, 0.5? Okay, details. Water boils at 90 degrees at sea level. Hypothesis is this: falls at sea level, water boils at 100 degrees centigrade. At sea level, water boils at 212 is false. Recall. is happening? My God. Okay. So Mars is known as the red planet because its surface contains iron oxide and all of that. Iron oxide gives Mars a reddish appearance. So these are not factual, which we don't know. That's what it's saying. So 50% score. It only matches why it's called 50%, but I mean what it is called, but why it is called is not there. So that says 50% it's fact, right? And then what is the Mount Everest is 8.8 kilometers tall. The answer is 8,848 meters above sea level. So this is 80% match. And then there are more details coming in here which are not there in the output. So it's 80% that it says it match. Hamlet was written by Charles Dickens. But the actual answer is Hamlet was written by William Shakespeare. So basically what it's trying to see, whatever the output that we are giving, it's trying to verify the truth of this sentence with the truth that is provided by the model. So we are not trying to see the similarity of the answers here. Okay, we are trying to establish the correctness of the answer here. Earlier, when we do the answer match, okay, if I am giving a wrong answer and the model is also giving the wrong answer, it will just compare and say, hey, these two are matching. And so the test is passed. Now here, even if you give wrong answer, it's trying to verify if this answer is correct or not as provided by the model itself. So model is giving Shakespeare, you are saying Charles Dickens. So these two does not match. Right? So this is true. This is false. Hamlet is a written work. Premises, this is what the premise is. We say it was written by Charles Dickens. This which is hypothesis, which is false. And the model gives you the William Shakespeare. So that's why this failed. So similarly, it will do, we say penguins can fly long distances. But when it verified the answer with the model's answer, it figured out, no, this is wrong. So it says 0. It failed. So this is not correct. So this should actually match because it has chambers, 4 chambers. It has more, but I don't know why it chose to have false, 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 all of these. Precision. I'm not able to see this somehow. Okay, but you get the idea, right? So that is what it should be doing for the factual match. Okay. Let's take some other better example here. Say PI detection. Okay. So whatever the answer you're getting, whatever the model is producing the answer, or whatever the input that you are sending in, does it have a PII in that, personal information? Okay. So what kind of personal information you can, the evaluator can detect? You can switch on off any of these to make sure, hey, is there any of the PII information, personal information in the input that is provided. I have a data set here with personal information like emails, credit card numbers, phone numbers, and all of this, right? And then I have switched on these to detect credit card, crypto, email, IP address, location. So any of these, we can switch on and see which ones it is detecting. It has the PII detection using the model. Okay. Again, GPT 5.2 we are using here. There's only one model. We just give the input and see whether that model detects the PII information properly or not. Again, as I said, we can also write guardrails for that and then make sure the PII detection can be done. So if we go to so one second. Let me check this. Yeah, Protecto AI. So if you go here, there's a lot of work has been done on this. This is evaluated. Okay. Let's see here. Okay. So LLM Guard is one library from the Protecto AI. They also have the full-fledged application. We will see this demo later when we talk about it, how to use this. But see, if you see here, your input and output flows through some of these guardrails that you create. It's like gates. They pass scanners. You pass through the scanner, just like you put your luggage in the airport in the scanner. It will detect whatever you have configured that scanners for. Different scanners available, and then you can write your own scanner also, like anonymized code, competitors, substrings, topics, code, gibberish, invisible text. It can detect prompt injection, language, reject secrets, sentiments, token limit, toxicity, right? So in this, you also have your PII information also you can detect in this. Okay. So if you look at this, if you take any of this, let's say JSON scanner. So it's just a library that you can create that scanner and then add it. So it will try to detect if the output is in a JSON form, valid JSON format or not, because you're sending out to the applications. So you can add a guardrail to verify if it's in the proper format or not. So competitors, you can give a list of competitors that you want to check if it is referring to any of them in the answer. So it will detect that answer and then give it to you if there is any of those names that are mentioned in the output or the input that you want to. If you want to say code, any of this, it will detect if the model is sending out code or generating code which you don't want to, or input, basically if they are sending some malicious in the tags or any code to execute, so it will also verify that, check that. So we'll come to this again. So just I wanted to bring up here because it's more or less like PII input here from the data set. So when you evaluate the workflow, let's see here. Now, status failed, PII detection, person likelihood 85%. So it detected the person, John Smith. Here it detected email address and email address, 2 email addresses. So johnson@company.com, mikewilsonenterprise.org. It detected 2 email addresses. Here it says IP address is detected, twice. So this is one IP address and this is one IP address, right? So it detected 2 IP addresses in this location. So it gave your address, like London branch. It said New York office. So it detected possible location and 2 locations, New York, London, and then a phone number it detected. Then it has IBAN code. Since you put IBAN GB29 something, you checked out to check the IBAN. So it's like crypto Bitcoin wallet number. So it detected, it's saying crypto was likelihood it failed. Okay, so just giving the wallet numbers. So it detected the crypto in the output. So on and so forth, whatever you have enabled. So all of that it will check and give out the PII detection, IBAN code, person, location, phone number, and all of this. So this is off the shelf. You can also write your own evaluations, and then there are a lot of other things that you can explore each one of. But the thing is, you have to figure out what is the input data set that you need to provide for each these of kinds. Some need only the input, some need input and expected output as well. So, and you also have to have a proper test data based on the scenario that you're trying to test. So if we go generate, we want to do blue and rogue scores. Okay, so I've created here another data set. Same data set I have taken, how I reset my password. So for the answer match, we have taken, right? Earlier, pass fail. The same thing I have taken to the LLM model. Okay, the output, I have 2 entities here, blue score, rogue score, output from the model and output from the data set, expected output. And this evaluator will give out a score. What is the blue score? And this evaluator will give out what is the rogue score for the same output and the expected output. Since I have 2 outputs coming here, I added 2 outputs in the end, blue score and rogue score coming from these 2 evaluators. So I can run this, run evaluation. So you get these scores 0.03, 0.26, 0.1, 0.15, not very sure. Maybe I'll have to read out what exactly the blue and rogue represent. I know it's a NLP, natural language processing metrics. Yeah, crucial metrics in NLP for evaluating generated text. Bilingual evaluation under study, focusing on precision for translation, how much generated text matches reference. Recall oriented under study for gisting evaluation, focusing on recall for summarization, how much reference content is in the generated text. Okay, so a similar kind of a little bit different metrics that you would use in benchmarking and natural language processing capabilities. So, but these are two different metrics that you can also measure as part of your evaluators. It measures the precision word sequences. This measures how much of reference text context appears in the generated text. So it's the quantity, how much of content is there in the actual output. This refers to precision, how many inexact sequences, something like that it has. How it works and variants, all of this you can look at. But yeah, so you can implement all of these. So why the scores are very low? Because see, these answers are very detailed. We have a very small answer here. So that's why the scores are low when you are comparing these two. Okay. So that is about how you do the evaluation. And then, so as I said, it's a part of your QA. You can also put it as part of your production applications as well. You just plug it in when just before your output goes. So like guardrails are always, you do some kind of QA, but also you put it in the production also, so that it keeps logging. You want to log, if there is any output from the guardrails, if anything fails or if anything is detected, you want to log it, so that you want to verify and go back and see who's done that, what kind of information was asked, or what kind of information was trying to be, how you stopped any of those information leaks or violations, basically. Okay, so this is you can add this into your production, or you can add guardrails. Mostly you add guardrails here as a libraries, production libraries you can create and add. But if you have UI, you can add these evaluators. You can export and evaluate, add this as the evaluation to any of your application. You can do publish, export, you can export, you can do API reference, all of this. If you want to invoke this, connect the data set to this from the external sources. Okay, yeah, so that's about the evaluations in the LangWatch. You also have evaluation in other platforms as well. You can check. Most of the platforms provide their own evaluators. But this is the high level of what evaluators does and how do you check the work using the evaluators, check your models. All right. Okay. Any questions before we move on to the next topic? Ganesh, all good? Any
Yeah,
question?
I'm good.
Okay.
Yes.
Great. All right. So let's get into the next topic. So we talked about the models, right? So all of the practice that we have been doing, we are using OpenAI key and connecting to OpenAI. For example, any of this, if we go, we are using the OpenAI keys here. OpenAI API key to connect to the OpenAI models, right? So how do we if we want to use, how do we just download a smaller model and then can run locally and connect to it locally so that, you don't have to pay for anything. Okay, there are some smaller models which you can run on your laptop and connect to it as a LLM model. You don't need to go cloud provider to process that, right? So one of that platform that provides is Olama from Meta. Okay. So if you go to Olama, easiest way to automate your work using open models. So which means you can still connect to the open models on Hugging Face, or you can choose to download them. Some of them which are available to download, you can download and then run it locally. Okay. So if you say download, I have already downloaded this. You can go and download for Windows, Mac, Linux, whatever. So once you download, you will get a files, Olama setup. You can run and install just like anything you download from an application. You download and install. When you open that, you get this, right? Now here you can directly chat, select a model and chat, or it will download. So here you can see there is a download. Okay, so you can download this to your local. Okay, so you can see here Gemma 3 1 billion parameters that I have downloaded. The smallest model, Gemma 3. 1.8 billion is DeepSeek. You can also download this. Okay. I'll just give a message. You can also download from there. Once I start communicating with it, it starts downloading using the Olama here. Okay, while that is downloading, now what you can do, so once I have downloaded a model, I have downloaded a platform, Olama. Now you can communicate with this model using the Olama application on your local. So once you do that, you open and say Olama list. So it will tell you which models are already downloaded, available. So it says Gemma 3.1b, Gemma 3, sorry, 1 billion parameters is the model that is available for you to interact with. Okay. Now, let me see where this. Okay, it's still going. Okay. So how do I access this model? Is just I can say Olama run, and then I have to give the model name, which model I want to run from here. So I'm running this model. Okay, now you have a prompt here. Now you're directly communicating with the model. So here I can directly give my prompt, whatever prompt I want to give, I can give. So you can check what is happening with this. Just switch off the Wi-Fi and work in local mode on the laptop and see whether you're still able to communicate with the model. That is the perfect test that you're running that locally, right? I did that. but now I cannot because the Zoom meeting will stop if I switch off the Wi-Fi. Okay. So let's say, tell me a fiction story in 10 lines. So it starts generating this for me. Just on the local. Now, I am doing this. Why am I doing this? Do I have to get here and then do on the command prompt, or how do I connect from my application? Correct? So we have to create an application and try to run that application locally and then use this model from the application to do whatever we want to do this, right? Not from the command prompt. So I want to write a Python based app and then use this locally from there, this model, so that I can get answer this. So let's stop this. Okay. So I came out of this. Okay. So what it started giving change? Why is it giving change? DeepSeek.
Yeah, I have a question. How did you get to this window, the one that you're sharing?
Sorry, come again.
How did you get to this window
It's
that you're
just a
sharing?
yeah. Once you download and install this, right? It's just an application Windows that you can open.
Oh, okay.
Okay, and then you can directly it will give you all the models that are available on Olama that you can download. Now, so I will start a new command prompt. To Olama list. See, now I have this model downloaded. So I have two models. This is just 815 MB. This is 5.2 GB size. Okay. So these are the two models available. So you can download models and then use any of the models locally to connect to it. Okay. Now, we talked about how do we do the applications, right? So what I will do here, I will go in this. I will just create a new folder for my project. So there are several ways of doing this. So what I'm going to do is now open my VS Code and then start writing, create the project structure in that, and then try to execute. There are some steps. I know most of you must have already given, but there are 4 or 5 commands that you just run and then create a project. You can follow this. I'll give you those commands as well. I can just paste it here. You can copy it and save it. Or later we'll also create a document for that. So first thing here, I'll go say new folder. Okay. And then say cohort 6 test local. Now just open this folder, right click, go and open in terminal, and then say code dot. So open the VS Code application, the current folder. So it will just bring up my VS Code app here. And then this window. Just this. Sorry. Okay, so I have this project opened here. Now, if I go here, view terminal within this, right? So here I can start writing my commands. So there are some commands I use. UV, probably if you have in this, you can go, there are extensions, and then you can see what you have installed. So most useful ones are .env to read the env file. GitHub Copilot, if you need Python, you need UV toolkit is one thing to enhance the. It's just like your VNV, virtual environment, to create virtual environments. This is very good. So I installed these extensions, UV toolkit and all of these ones. So I'll be using UV for to create the project here. I just have the folder name. So what I will do here, as I said, I have a set of instructions. Okay. First one is UV initialize the project. So it will initialize the project, then you will get all of this. There is a main, there is git ignore, Python, PyProject, readme, and all of this. Then you create a virtual environment. So before you can create a file here to say requirements.txt. This is where you add all the libraries. Remember in our here, you are doing this, install all of these libraries, right? LangChain, OpenAI, and all of this. So that is what you put here to import. So I will import Olama library. So that is what we are going to use. Install this Olama library because that's what we are going to use in the to interact with the local model. So I just have to say the library names here in the file. So we'll use this file to install later. So first we did UV init. Okay. Next we will do create a virtual environment for this project. So UV, VENV, virtual environment. So it will create, see now, if you see here, VENV scripts activate. So you created a virtual environment, second step. Third step is to activate that virtual environment. You just run this here, same command. Your prompt will change from this. Now see here, it says now you are in this virtual environment. So whatever libraries you create, whatever files the Python environment you create, you add libraries, dependencies, everything, versions of the Python, everything will be in this virtual environment. It does not conflict with other projects or other dependencies or other versions in the other projects. Okay. So just 3 steps: UV init, UV VENV, and activate the VENV. Now I have requirements .txt. I want to install this libraries. So to install, I will just say UV pip install -u or requirements.txt. Read the requirements.txt file and then import all the libraries that are in this. So you can just keep adding, any libraries here. Let's say if you want LangChain, okay, just put LangChain here. So it will install all the Olama as well as LangChain, all the libraries here. So your libraries are all set, dependencies are all there. You have all the libraries. Now you can go and write your code anywhere here. So this is hello. I can go and run this. So see the project is executed. Just run this. Now here, what I can do, I can say call the LLM, my local LLM using Llama. But for that, I have to import, right? First, I will say import OLama. And then I will use this code snippet. Here. So olama.chat, model name, I'm giving this 3.1b. And then role is user, content is the question. How can I connect to a local model? You can send any question here, just like we were doing in the Google Colab. And then you get the response, print response. That's the simple application that you're running. And then you are connecting to your local. So if you run this, is the one. And now it's interacting with this model. It'll take some time because it's local. It has to bring up, talk to the model, run it, and then get the response, right? Yeah. Yeah. Okay. It takes time, local, right? So it takes time, but the point is you can talk to the model locally and then use it for free. Any models that you want to download from, Olama. So if you go here and, we have DeepSeek R1. So you can change this, but I don't know why it is giving not English language. So you have to check that. Or you can download any other model and try to communicate with that. So I change the model here and then run it again. Let's see if we can add this. And say stuff. This stuff. Let's see. Let's see what it comes back with. Then we can try and see if we can change the output language here. Actually, here I have, yeah, that's fine. Taking very, very long time. It was giving faster on the command prompt because we are already running from here, but from this environment, it's taking a lot of time to, I think it's trying to invoke and get the model up. Or this is a bigger model, 5 GB model. So it might take more time. To go for the, if you want to test, I think this is the 1 billion smallest model. There's a 4 billion one, 12 billion, but I think you need more RAM to run those 27B. These are cloud. On cloud, you want to connect using Olama. The Quen 8 billion, 4 billion. In minimum, I guess, yeah, 4 billion is the one that is smallest. But Gemma is the smallest of all with 1 billion. Here, okay. One second. Okay, so anyways, it's valid model format. No, we are getting just, this is the actual response, I think. Yeah. Okay. You got the response. It is giving in English here, so no worries. To correct a local model, Hugging Face, using Hugging Face, follow these steps. So this is the actual response from the model that we are using. So that's how you can switch your model, and you can also how to package, create a project, just like what we did in the Google Colab. So you can add modules here, you can add agents here, you can add your proper structure with modularization. You can have agents in one folder, you can have tasks in one folder. If you're using Crew AI, you can have libraries, you can have constants, environments, config files, YAML files, everything in the project structure. So tomorrow we will go through another project using the anti-gravity, the same like this VS Code only, another IDE. We'll create another project, and we have Docker to build the container and then deploy onto Google Cloud Run. Okay, so that's what we will go through tomorrow. With that, we'll have the end-to-end, like building applications, agents, and then deploying it on the Cloud Run. So that will complete. So it's more DevOps kind of a thing, but we will touch up on it and then see how we can deploy it onto the Google Cloud Run. It might have a little bit of components that some people may not be aware or tried earlier. But yes, so that's one architecture where you build a project like this, you build a container, containerize it, push it into build a container image, and then pull the container and deploy it on the Cloud Run Google. So that will give you deploy endpoint. So you can access this complete application from that endpoint. And it will automatically scale based on number of users and API calls. Okay, so that is what we wanted to talk about today. So we have came in the introduction to building the VS Code projects and all of that. So as I said, let me give you these initializing requirements, and then you can use this code also in the main.python and then run this. I'm putting it in the chat here. You can copy this. But of course, there will also be recording. Again, you can use that. Yeah, process. First, create a folder, open it in terminal, type code dot. But before that, yeah, you have to install the VS Code for Windows. Add some these extensions into it. Okay, and then you are ready to go. You may not need all of this right now, but at least .env, Python, and UV toolkit. If you add these three, I think it should be good enough to get started. All right, so that's what we have to discuss today. Any questions? We'll do another 3 sessions. I know I have promised about the projects thing, but last week is a little bit hectic on the work side, so I couldn't spend time. I will try to get to it as soon as possible. We will continue that. So the other, this week and next week, we have another 3 sessions to continue. We'll talk about deployment tomorrow. Then next week, we'll talk about advanced topics like MCP and using MCP servers, building that on that stuff. And then any small topics I talked about, like guardrails and other stuff, architectures and that. The final session we have taken offline, so we'll also talk about the projects and that. Fair enough? Any questions before we wrap up today? All good? Yeah, Satya, all good. Ganesh, Deepak?
Yeah, okay.
Yes.
So what are we doing tomorrow?
Tomorrow we'll do the same. We create a project and deploy onto the Google Cloud. Containerize using Docker and push the Docker container onto the Google Cloud and deploy it on the Cloud Run.
Okay, thanks.
Yeah. All right, guys. Thank you so much. Appreciate it. Take care. We'll meet tomorrow then. Okay. Any questions, ping me offline.
Okay, thanks.
Yeah. Thank you. Take care. Bye.